Dear students, in this video, I'll explain you normal distribution. Normal distribution is a continuous probability distribution. And already we discussed exponential distribution. It is also a continuous probability distribution. If x is a continuous random variable having the probability density function f of x in the form f of x is equal to 1 by sigma into square root of 2 pi e to the power of minus x minus mu whole square divided by 2 sigma square, where x takes the values from minus infinity to plus infinity and mu is also varied from minus infinity to plus infinity and sigma is greater than 0, is known as the normal distribution. The mean of the normal distribution is mu and standard deviation is sigma. Mean is mu and standard deviation is sigma it is. Okay. Okay. We have probability of a less than or equal to x less than or equal to b is given by integration a to b f of x into dx. In the case of normal distribution, we have probability of a less than or equal to x less than or equal to b is equal to integration a to b f of x into dx means f of x, probability density function of the normal distribution is 1 by sigma into square root of 2 pi e power minus of x minus mu divided by root 2 sigma whole square into dx. With the help of this probability function, okay, it is very difficult to find the required probabilities because the integral in this right hand side of equation 1 is very tedious integration process it is, okay, and it is not easily integrable by the analytical methods. We need to go for numerical integration, which is also very tedious task it is. Hence, we think of standardization of the normal distribution. Put z is equal to x minus mu by sigma. This is a standard normal variate with mean is equal to 0 and sigma is equal to 1. Z is equal to x minus mu by sigma with mu equal to 0 and sigma is equal to 1. Then x is equal to z. Okay. This is a normal distribution becomes the standard normal distribution. Normal variate becomes the standard normal variate. Okay. With the probability density function f of z is equal to e power minus z square by 2 into 1 by square root of 2 pi. And f of z is the standard normal probability function. It is same as the probability density function of the normal distribution with mean is equal to 0 and sigma is equal to 1. And the graph of this standard normal probability distribution, standard normal density function bell-shaped curve. Okay, it is a bell-shaped curve. The total area of this curve is equals to 1. It is symmetrical about the line z is equal to 0. It varied from minus infinity to plus infinity. Because it is symmetrical about the line z is equal to 0, area from minus infinity to 0 is equal to 0.5. Similarly, area from 0 to infinity is also equal to 0.5 it is. Okay. And with the help of the standard normal table, we are able to find the normal table. We are able to find the required probability values. Now we'll see the problems of normal distribution. If the lifetime of a certain types of electric bulbs of a particular brand was distributed normally, particularly they are asking it is distributed normally with an average life of 2000 hours. Okay, average life means mu is equal to 2000 hours and standard deviation of 60 hours, sigma is equal to 60. If a firm purchases 2500 bulbs, that is total frequency is equal to 2500. Find the number of bulbs that are likely to last for more than 2500 hours, less than 1950 hours, between 1900 and 2100 hours. Okay. The lifetime of a certain types of electric bulbs is normally distributed. Okay. X is the normal variate. Z is equal to x minus mu by sigma. Nothing but x minus 2000 divided by 60 is a standard normal variate. First required probability is find the number of bulbs that are likely to last for more than 2500 hours. Okay. Mean is equal to 2000, sigma is equal to 60. Probability of x greater than 2500 is equal to probability of x minus mu by sigma greater than 2500 minus mu divided by sigma. Mu is 2000, sigma is 60, substitute, and x minus mu by sigma is nothing but z. Okay, probability of z greater than 8.33. Okay, means 8.33 is a value. Z greater than 8.33 means area from 8.333 to infinity we required. Okay, this area is nothing but area from 0 to infinity minus this extra area we need to subtract, that is area from 0 to 8.33. That's what I have written here. Probability of z greater than or equal to 0 minus probability of 0 less than z less than 8.33. Area from 0 to infinity is 0.5 minus area from 0 to 0.833. I have written it as a of 8.33. And from the table, a of 8.33 is 0.5. 0.5 minus 0.5 is 0 it is. So the number of bulbs that are likely to last for more than 2500 hours is 2500 into 0 is equal to 0. Look at this. How to find area from 8.33 with the help of normal table? Just Okay, this is the normal table, normal probability table. Here Z values they have given. So Z value from 0 to 2, maximum 3 they have given. 8.33 we required. Okay, from 3 onwards. Okay, 3 onwards, area corresponding to Z value is 0.5 itself it is. Okay, for 3 itself it is 0.5. For 3.1, 3.2, 3.3, 3.4, 3.9, 4, 5, 6, 7, 8, 9, 10 up to infinity, that area will be 0.5. That's what I have written. Is probability of x less than 1950. Probability of x minus mu by sigma less than 1950 minus mu by sigma. X minus mu by sigma is z less than 1950 minus mu value is 2000, sigma value is 60, that is minus 0.83. Z less than minus 0.83 means area from minus infinity to minus 0.83 we required. Okay, because it is symmetrical curve, area from minus infinity to minus 0.83 is same thing as that of area from 0.83 to infinity. That is probability of Z greater than 0.83. How to find this means area from 0 to infinity minus area from 0 to 0.83. Area from 0 to infinity is 0.5 minus area from 0 to 0.83. I have written it as A of 0.83. 0.83. Okay. Again from the table it is 0.8 at 3 we need to require look at the value. That value is 0.2967, that's equal to 0.5 minus 0.2967 is 0.2033. Number of bulbs that are likely to last for less than 1950 hours is 2500 into 0.2033 comes out as approximately 508. Next required probability is number of bulbs between 1900 and 2100 hours. Probability of 1900 minus mu by sigma less than x minus mu by sigma less than 2100 minus mu by sigma. X minus mu by sigma, I call it as Z, and if I substitute mu and sigma values and if I simplify it, comes out as probability of minus 1.67 less than Z less than 1.67. Okay. Area from minus 1.67 to 1.67. Okay. We can split it as area from minus 1.67 to 0 plus 0 to 1.67. That's what I have written. Area from minus 1.67 to 0 is same thing as that of area from 0 to 1.67. So, probability of 0 less than Z less than 1.67 plus probability of 0 less than Z less than 1.67. Okay, both are same terms. 1 plus 1 is 2 times probability of 0 less than Z less than 1.67. 0 to 1.67 area I have written as A of 1.67. Okay, 2 into from the table 1.6 okay at 7 becomes 0.4525. That comes out as 0.905. So the number of bulbs that are likely to last between 1900 and 2100 hours is equal to 2263. Next is next problem. The marks of 1000 students in an examination follows a normal distribution with mean 70 and standard deviation 5. Find the number of students whose marks will be less than 65, more than 75 and between 65 and 75. Here mean is equal to 70, mu is equal to 70 and sigma is equal to 5. Z is equal to x minus mu by sigma is the standard normal variate. First required probability less than 65. Probability of x less than 65 we need to find. More than 75. Probability of x greater than 75 we need to find. Between 65 and 75. Probability of 65 less than x less than 75 we need to find. First required probability is probability of x less than 65. That is equal to probability of x minus mu by sigma less than 65 minus mu by sigma. X minus mu by sigma is Z less than 65 minus mu is 70, sigma is 5. 65 minus 70 is minus 5 divided by 5 is minus 1. Z less than minus 1. Z less than minus 1 means area from minus infinity to minus 1. It is same thing as that of area from 1 to infinity means Z greater than 1. That can be found by area from 0 to infinity minus area from 0 to 1. That's what I have written as probability of z greater than or equal to 0 minus probability of 0 less than z less than 1. If you don't know how to write this, you can write area from 0 to infinity minus area from 0 to 1 inwards also you can write. Area from 0 to infinity is 0.5 minus area from 0 to 1, just have written it as a of 1. Okay. A of 1 from the table it is 0.3413. That is equal to 0.5 minus 0.3413 is equal to 0.1587. So the number of students scoring less than 65 marks is equal to total frequency. Total number of students is 1000 into 0.1587 is equal to approximately 159 students. Second required probability, probability of x greater than 75. Probability of x minus mu by sigma greater than 75 minus mu by sigma. X minus mu by sigma is z greater than 75 minus, I substituted mu and sigma values, z greater than 1. Z greater than 1 means area from 1 to infinity. That can be written as area from 0 to infinity minus area from 0 to 1. Area from 0 to 1 is a of 1 I have written as area from 0 to infinity is 0.5. A of 1 value is 0.3413. 0.5 minus 0.3413 is 0.1587. 0.1587. So the number of students scoring more than 75 marks is equal to 1000 into 0.1587 is equal to approximately 159. Next required probability is probability of 65 minus 65 less than x less than 75 is equal to probability of 65 minus mu by sigma less than x minus mu by sigma less than 75 minus mu by sigma. Means we are standardized here. 65 substitute mu and sigma values, call x minus mu by sigma as z. Probability of minus 1 less than z less than 1. Area from minus 1 to 1. We can split it as area from minus 1 to 0 plus 0 to 1. Area from minus 1 to 0 is nothing but area from 0 to 1. So it becomes 2 times area from 0 to 1. 2 times A of 1 value from the table is 0.3413. It is 0.6826. So the number of students scoring marks between 65 and 75 is equal to 1000 into 0.6826 approximately equal to 683. Next problem. This is the model question paper problem. First problem is also a model question paper problem. Okay. The IQ of students in a certain college is assumed to be normally distributed. Assumed to be normally distributed with mean 100 and variance 25. If two students are selected at random, find the probability that both of them have IQ between 102 and 110. At least one of them have IQ between 102 and 110. At most one of them have IQ between 102 and 110. Okay. Mean is equal to 100. Variance is 25. So the standard deviation is equal to square root of variance, nothing but 5. Z is equal to x minus mu by sigma. X minus 100 divided by sigma 5 is a standard normal variate. Probability that the IQ of students between 102 and 110 is P of 102 less than x less than 110. Okay, probability of 102 minus mu by sigma less than x minus mu by sigma less than 110 minus mu by sigma. Okay, 102 minus 100 divided by 5 is 0.4 less than x minus 100 by 5 is z less than 110 minus 100 divided by 5 is 2. Okay, area from 0.4 to 2 we required. That is area from 0.4 to 2. That can be splitted as area from 0 to 2 minus area from 0 to 0.4. Area from 0 to 2 is A of 2 minus area from 0 to 0.4 is A of 0.4. From the table, A of 2 value is 0.4772 and of 0.4 value is 0.15542. Okay. So that P value is equal to 0.32183 and Q is equal to 1 minus P. Okay, 1 minus P value is 0.32183 comes out as Q value 0.67817. Since this probability is same for each student, then the required probability that out of two students, first we required the P value with the help of the normal distribution. Now, since out of two students, they asked, since this probability is same for each student, then the required probability that out of two students selected at random, we have from the binomial distribution. Now we need to use the binomial distribution. Already we discussed binomial distribution. Its probability mass function is ncx p power x q to the power of n minus x. X takes the values from 0 to n. Okay. N value out of two students they asked. So n is equal to 2cx. P value just now we calculated. Q value also we calculated. Substitute p, q values. X take the values from 0 to 2. Now, first required probability. Both of them have IQ between 102 and 110. Okay, both of them means only two students are there. Required probability is P of 2. Substitute x is equal to 2 in this probability density probability mass function. It comes out as 0.1036. Okay, at least one of them have IQ between 102 and 110. At least means minimum 1 or more than that. Probability of x greater than or equal to 1. Okay, x greater than or equal to means x take the values only 0, 1, 2. X greater than or equal to 1 means P of 1 plus P of 2. Substitute x is equal to 1. And x is equal to 2 in the probability mass function of the binomial distribution and simplify it. It comes out as 0.5015. Next is at most one of them have IQ between 102 and 110. Means at most means maximum 1 or less than or equal to 1. Probability of x less than or equal to 1. In a complement way, we can write it as 1 minus probability of x greater than 1. 1 minus, which is a value greater than 1 means it is only 2 because only 2 students are there. 1 minus P of 2. The first case already we find P of 2 value, substitute that value and simplify it. It comes out as 0.8964. I hope you understand it. Okay. Problem is also exactly similar, okay, that to the previous problem. The mean weight of 500 students during a medical examination was found to be 50 kgs and standard deviation weight 6 kgs. Assuming that the weight are normally distributed, find the number of students having weight between 40 and 50 kgs, more than 60 kgs, given that phi of 1.67 is equal to, here itself in the table, okay, in the problem itself they have given the normal probability table value. With the help of this easily we can do. Mean is equal to 50, sigma is equal to 6. Total frequency, total number of students is 500. We need to find the probability with P x value between 40 and 50 and probability of x greater than 60. Z is equal to x minus mu by sigma is a standard normal variate. Probability of 40 less than x less than 50 is equal to 40 minus mu by sigma less than x minus mu by sigma less than 50 minus mu by sigma. That is equal to, substitute mu and sigma values and call x minus mu by sigma as z. Then it will be probability of minus 1.67 less than z less than 0. Okay, means minus 1.67 to 0 we required. Okay, this area is something else, that of area from 0 to 1.67. Probability of 0 greater than z greater than 1.67, or else area from 0 to 1.67 is phi of 1.67, and in the problem itself they have given phi of 1.67 value is 0.4525, or else you can check it out from the normal table. Definitely it's equal to 0.4525. 1.6 at 7, if you look at the value, it is 0.4525. Number of students having weight between 40 and 50 kg is equal to 500 into 0.4525, approximately equal to 226 students. Probability of x greater than 60 is equal to probability of x minus mu by greater than 60 minus mu by sigma. X minus mu by sigma is z. Simplify, substitute mu and sigma value and simplify. It is 1.67. Probability of z greater than 1.67 means area from 1.67 to infinity. Can be written as area from 0 to infinity minus area from 0 to 1.67. Area from 0 to infinity is 0.5. Area from 0 to 1.67 is phi of 1.67, and phi of 1.67 value 0.4525. On simplification, it is 0.04775. Number of students is equal to 500 into 0.0475, approximately equal to 24 students. Next problem. In a normal distribution, 31% of the items are under 45 and 8% of the items are over 64. Find the mean and standard deviation. This is a little bit a different problem it is. Just here we need to find the, instead of finding the probability values, we need to find the mean and standard deviation. Mu and sigma values we supposed to find. By data, 31% of the items are under 45. Probability of x less than 45 is 31%, and 8% of the items are over 64. Probability of x greater than 64 is 8%. With the help of this, we need to find out mu and sigma. Z is equal to x minus mu by sigma is a standard normal variate. Probability of x less, given probability of x less than 45 is 31%. Probability of x minus mu, it is actually x minus mu by sigma less than 45 minus mu by sigma is equal to 31% is nothing but 0.31. X minus mu by sigma is z less than 45 minus mu by sigma, I called it as z1 is equal to 0.31, where z1 is equal to 45 minus mu by sigma. Probability of z less than z1, okay, we'll think z1 will be in the, okay, positive region it is, okay. That can be splitted as probability of z less than or equal to 0 plus probability of 0 less than z1 is 0.31. Probability of z less than or equal to 0 means area from minus infinity to 0, that is nothing but 0.5. Area from 0 to z1 is phi of z1 equal to 0.31. Therefore, phi of z1 is equal to 0.31 minus 0.5, it is minus 0.19. Now we need to find out the z1, okay, corresponding to the area 0.19. From the table corresponding to the area 0.19, z value is 0.5 it is. Hence, z1 is equal to minus 0.5. z1 is 45 minus mu by sigma is equal to minus 0.5. On simplification, it comes out as 45 is equal to mu minus 0.5 sigma. Call it as equation 1. Second data they have given is probability of x greater than 64 is 8%. Probability of x minus mu by sigma greater than 64 minus mu by sigma is 8%, means 8 by 100, nothing but 0.08. Okay. X minus mu by sigma, I call it as z. 64 minus mu by sigma, I call it as z2. Okay, where z2 is equal to 64 minus mu by sigma. Okay, how to find probability of z greater than z2 means area from 0 to infinity minus area from 0 to z2. Once again, we'll think z2 will be in the positive region it is. Okay, that's equal to 0.08. Area greater than or equal to 0 means area from 0 to infinity is 0.5, and 0 to z2 area I denote it as phi of z2. Okay, phi of z2 is equal to 0.5 minus 0.08. Okay, that is 0.42. Now, corresponding to area 0.42, z value is 1.4. Therefore, z2 is equal to 1.4. z2 is 64 minus mu by sigma is equal to 1.4. On simplification, 64 is equal to mu plus 1.4 sigma. Now solve equations 1 and 2. Two equations to 2 unknowns mu and sigma. With the help of calculator, easily you can solve that. Okay. If we solve equation 1 and 2, it comes out as mu is equal to 50 and sigma is equal to 10. This problem is also exactly similar to that problem at us. Okay. Easily you can do this problem. Okay, I hope you understand the normal distribution.